Alright, let's do a video of using Sage Math Cell to do our polynomial interpolant. So if we go to our interpolation page here, go down, I now have a link, polynomial interpolant here for Sage code. If you click that link, you should get a text file like this. Now to use it, go back here, click your Sage Math Cell, opens up a new Sage Math Cell. We'll make it a little bigger here so we can see things when we paste this in, but just go here, highlight everything, do a Control-C for copy, Control-V for paste, and it puts everything in here. And so now let's look at what we have. So everything that follows a pound sign or hashtag or number sign, it's got a lot of different aliases, I guess, is just a comment. It's to help you see what's there in the code. So here the first thing we do is load some libraries, since Python doesn't load them all as an efficiency thing. So we're importing NumPy, or a numerical Python. That's mostly good for arrays. Then we want to plot, and so we're importing matplotlib, and in particular the pyplot libraries of that. Now the as part is just something so that when I write the code, I don't have to write NumPy or this whole thing, matplotlib, pyplot, and so forth. So I put as, and that makes an alias, so it's just shorter to write things. And then from the scientific Python, I'm importing the interpolate. Actually, now that I think about it, I don't need that anymore, so I'm going to get rid of that out of the code for now, so we won't have that in there. Just turned out that it wasn't quite doing what I thought it was, so I've changed some things. Now for you, in the end, in order to just create a plot, what you need to have are X and Y data. And so here are my X and Y data that I've been using quite a bit. 0, 1, 2, 3, 5, 1, -1, 5, and that we can create a cubic polynomial to interpolate those points. So those are my X's, those are my Y's, and so I simply need to put those in. Those should never be a lot of points, because yeah, we don't really want to, typically you aren't going to interpolate anything over probably 5th or 6th degree polynomial usually. And so those are pretty easy to enter, but that's all you have to enter are the data, the X's and the Y's. Make sure the X's increase in order and the Y's are the same number as the X's. But then once you have that, these two lines, they actually do the polyfit. They get the coefficients, and oops, I've got that wrong. Not sure why. I know I changed that. So that should be n. That should be n minus 1. And I'll fix all that in the actual code. Then 1 and C 0. I had changed that once. I'm not sure when that got changed back or what I did to copy something, but at any rate, that is the order they go in, from highest degree to lowest degree, probably just the way you would want them to go. And so this just finds those coefficients, prints them out. Next, this is the more technical stuff. This is creating a polynomial definition, and it actually creates the function that I can evaluate, and I can do it in this p of x form, so that's nice. And you know, you don't really have to worry about that. Then I go through and create a bunch of x values to interpolate because I want to make a nice plot. I create 101. Oh, if it's 101 points, well, I'll tell you. I think I originally had 100 points. So I'll do that, and that'll make 101 points. Doesn't really matter. I could have changed this to the 100. Should work nicely. So 101 points, and all along between the lowest value x and the highest value x, just so we can get a nice looking curve. And then here's where I get the y variables, and I get to use the p of x new, and I just throw it all the y variables all at once. And then I plot out the points x and y, and that's in the B is for blue, and the O there then after that is to make them dots. And then here's the new data to make the curve, where I interpolate all sorts of points in there, and I'm doing that in yellow and making that a nice continuous curve. So, you know, once pretty much you just have to put in the data, then hit evaluate, and there we have our beautiful curve. I'll make that a little smaller now so we can see it all, but there's the curve. If you wanted to use different colors, you know, you could go in here and change the y to, you know, make that blue, make the points yellow, and most of the colors are what you would expect. White is W, red is R, green is G, cayenne or cyan is C, magenta is M. Black's sort of the only weird one because you got blue and black. Black is a K. Now, so that does it. You know, pretty much you just put in your data, hit evaluate, and go from there. Now, if you want to actually get evaluate at a particular point, suppose I want to evaluate this thing at 1.5, then what I can do is, you would think I should just be able to go like this, p of 1.5, so that'd be 1.5. You would be mistaken though, and that is because I made this to take lots and lots of values at a time. So you see, if I hit evaluate, it does the plot and everything like it's supposed to, but then see here it says it doesn't know what it's doing. It's giving me an error, and it says the problem is this object right here has no length. Okay, so that's an easy fix. If I want to know 1.5, I just have to do this slightly cumbersome thing of putting both the round and the square brackets around it. Now if I evaluate, come down here, I get the plot, and it says array. You know, I could get just the minus 0.625 if I wanted to. We're not going to worry about it. Now notice I didn't even say print. To be safe, you could say print around it like that, evaluate. And now you see when I say print, it doesn't put the array, but it still puts the square brackets. That's okay, I can live with that. If you wanted to go a little further than that, I believe if we do this, which if you haven't had any Python programming, likely you have no idea why I just did that. But I think if I do that, then you see I just get the number. Okay, but like I say, just keep it simple. You might want to use the word print like I did up here with print C, just to be safe that it does print it out. But other than that, it's just P of 1.5. I just have to remember to do both round and square brackets. So there you go. That is creating a nice interpolant plot along with the data. It shows me the coefficients. So I've got x cubed minus 2x squared minus 3x plus 5. And there you go. So once the code's there for you, makes it pretty simple.